I'm going to start with just a very quick recap on why we are concerned about black carbon emissions. Black carbon is a short-lived climate pollutant produced by the incomplete burning of fossil fuels. It has an impact over 3,000 times that of carbon dioxide on a 20-year global warming potential basis, and it makes up around a fifth of international shipping's carbon dioxide equivalent emissions. When released near to the Arctic, black carbon has a disproportionately high impact. Not only does it contribute to warming while in the atmosphere, it accelerates melting if it deposits onto snow and ice. The melting snow and ice exposes darker areas of land and water, which then absorb further heat from the sun. The reflective capacity of the planet's polar ice cover, the albedo effect, is severely reduced. More heat in the polar systems results in increased melting and a feedback that contributes to Arctic amplification of climate warming. It is also an air pollutant that has a negative impact on human health, including respiratory and cardiovascular diseases. The Arctic is a major climate regulator and is now considered by scientists to be warming as much as 4 times faster than the planet as a whole. It's an important ice habitat for wildlife with unique ecosystems supporting a huge productivity of plant and animal life in the oceans. And it is a highway and provides cultural identity for the Inuit people and other indigenous communities. But we are losing Arctic sea ice at a rate of around 13% per decade over the last 40 years, and the older multi-year ice is disappearing. This has unprecedented consequences for global biodiversity and for the loss of the Inuit homeland. It is now 16 years since a paper recognizing that black carbon is a potent climate forcer was first submitted to the IMO's Marine Environment Protection Committee. Then in 2010, 3 member states proposed that the IMO addresses black carbon by examining measures which would significantly reduce emissions from shipping having an impact in the Arctic. And at that time, it was envisaged that the reductions of black carbon could provide a short-term climate response that was considered to be absolutely necessary to forestall a climate tipping point, and could provide breathing time for the needed reductions in CO2 to take hold over the longer term. Supporting the proposal from Norway, Sweden, and the United States, the UN Economic Commission for Europe Convention on Long-Range Transboundary Air Pollution, or Air Convention as it's known, in 2011 urged the IMO to take active steps to reduce emissions from shipping of black carbon in the Arctic region, to improve public health, particularly for indigenous Arctic populations, and to slow the rate of warming. It recognized that action could be performance-based, requiring a specific emission reduction, or technology-based, such as requiring the use of low-sulfur fuels and diesel particulate filters when operating in the Arctic. It also acknowledged that a technological approach was probably easier to verify. 10 years ago, work was presented to the IMO from the Arctic Council's Arctic Monitoring and Assessment Programme, or AMAP, which showed the significance of close to Arctic and within Arctic sources of black carbon. In this work, the Arctic was defined as all regions north of 60 degrees north. This proposal to the IMO in 2013 concluded that emissions of black carbon north of 60 degree north were more significant than emissions at lower latitudes, and that this should be taken into account when establishing potential mitigation action for black carbon. 5 years ago, following the release of an intergovernmental panel on climate change special report on global warming, the UN's Environment Programme reiterated that fast and immediate action on short-lived climate pollutants, including black carbon, can avoid a 0.5 degree of warming by 2050, and such action will also avoid over 50% of the predicted warming in the Arctic by 2050. Thereby significantly decreasing the chances of triggering dangerous climate tipping points. Back in 2010, or 2011, when the work started, the IMO agreed to a three-step approach to address shipping source black carbon impacting the Arctic. The first step, to define black carbon, took a lot of debate before settling on a widely accepted definition. The second step was to agree how best to measure black carbon emissions and has resulted in three principal methods being identified. And the third step, addressing the control of black carbon emissions, remains ongoing. We'll hear more on this work from John Bradshaw shortly. The IMO is currently developing guidelines on recommendatory goal-based control measures based on the work undertaken to date. It was as early as 2010 that a study for the IMO on Arctic ship black carbon abatement options identified the 5 most promising abatement methods which would deliver immediate cuts of Arctic ship black carbon. The 2018 update of the study by one of the original authors stressed that the fastest option by far and of particular relevance for shipping's black carbon impact on the Arctic is an immediate shift to distillate fuels. Further workshops, working groups, and correspondence groups have operated over the years and have now evaluated a wide range of potential control measures, including changes to fuel, exhaust gas treatment systems, engine and propulsion system designs, and other provisions such as shore power, but without any decisions around concrete actions. Further consideration of mandatory measures requires concrete proposals to be put forward. In the meantime, the IMO has adopted other measures which are relevant to the work on black carbon. In 2021, a revision to MARPOL Annex 1 was adopted to address the risk of heavy fuel oil spills in the Arctic. The Arctic HFO prohibition starts to take effect from July next year and will eventually ban the use and carriage of heavy fuel oils as fuels in that part of the Arctic that is covered by the IMO's Polar Code, but not until July 2029. And that's assuming that all states apply the provisions, which is not currently the case. The IMO has also adopted a resolution which urges member states and ship operators to voluntarily use distillate or other cleaner alternative fuels or methods of propulsion that are safe for ships and will reduce black carbon emissions from ships operating in or near to the Arctic. Eventually, last year, an IMO correspondence group reduced a long list of potential black carbon reduction regulatory measures to 6 and identified those that can be applied to all existing ships immediately, which would include options such as a fuel switch or designation of emission control areas, and those that would require further work, such as a fuel standard or engine certification. The full list of 6 is on the slide. I'm not going to read them all out. Further discussion of this short list at this year's meeting of the IMO's Pollution Prevention and Response Subcommittee was limited, but IMO member states have now been called upon to present concrete proposals for regulatory measures to the next meeting of the Pollution Prevention and Response Subcommittee in early 2024. Other efforts are underway to address shipping's biodiversity and climate impact globally, and some of these will result in reductions in black carbon emissions. A recent workshop organised to explore the interface between energy efficiency and underwater radiated noise from shipping identified that the strengthening of the IMO's carbon intensity indicator and efforts to reduce emissions of carbon dioxide and to deliver the newly adopted IMO greenhouse gas targets are likely to involve greater use of slow steaming and moves to wind-assisted and even full wind propulsion. All of these should reduce underwater noise, as well as reducing emissions of both carbon dioxide and black carbon, but over time. The IMO isn't the only international body concerned about the impact of black carbon emissions on the Arctic. As mentioned earlier, the UN Air Convention and the UN Framework Convention on Climate Change have both emphasized the threat to the Arctic and global processes from short-lived climate pollutants, including black carbon. And in 2017, the Arctic Council adopted a pan-Arctic collective aspirational goal to reduce emissions of black carbon by between 25 to 33% based on 2013 levels by 2025. This followed the adoption in 2015 of a non-legally binding agreement or framework that set out a common vision for Arctic states to accelerate the decline in black carbon emissions and to significantly reduce methane emissions. Observer states to the Arctic Council are also encouraged to participate in the implementation of the framework, which includes an assessment of progress every 2 years. The third progress report, published in 2021, announced that the Arctic states were on track to reach the collective goal of a 25 to 33% reduction in black carbon levels by 2025. And during the Arctic Council Icelandic Ministerial in 2021, ministers committed to possibly updating the goal at the next Arctic Council Ministerial meeting. Disappointingly, the progress made in achieving this goal is not reflected in emissions from the shipping sector. In fact, emissions of black carbon in the Arctic have increased in a similar time period, but we'll hear more on this from the ICCT presentation shortly. And then finally, the Nordic Council has also committed to action on atmospheric emissions, recommending in 2021 that emissions reductions from heavy fuels should be achieved through the designation of emission control areas in the Arctic under MARPOL Annex 6, and that Nordic countries should completely ban the use of heavy fuel oils. I'm going to stop there and introduce our speakers now.